Hi, this is Mike Gidding from Third Eye Geoscience. As interpreters, we go to a lot of trouble to do a comprehensive job of interpreting the faults that we see on seismic. But how often do we see that interpretation properly represented in our well correlations? In this video, I'm going to run through a workflow for capturing faults as part of our well correlation. In particular, I want to talk about the use of the true stratigraphic thickness domain to display the fault gaps and make our well correlations look much more sensible. So let's get started. So the area that we're looking at here has a few different fault blocks, quite a lot of extensional faults. We're going to focus on this large green fault and this fault throw across here. And you can see that there are quite a number of wells, and those wells mostly intersect this green fault. There are a couple of wells over on the eastern side here, Boris and Peabody, that don't. So let's look at a well correlation. Our friends Boris and Peabody are sitting over here with pretty much complete sections of this shale. As soon as we've moved to the wells that are on the western side of the fault, the sections in the shale are much reduced, and that's because of the fault cutout. So how do we capture the information that we've learnt from interpreting as formation tops, or in this case fault tops? So I'm just going to change the layout. So we have to start with a decent well tie, and I'm not going to go through that now. Let's have a look at this well, Rocky 1. You can see that we have got a good tie, and everything seems to be working very nicely in terms of my formation tops, where they are compared to the markers that I have in the well, but we don't have this fault captured. So the first thing we want to do is we want to make sure that our time-depth relationship is up to date, and that anything that we add to a well correlation is immediately in the right place on our sections. So to do that, what we're going to do is we're going to be in the synthetic panel, making sure that we have edit mode turned on. When we have edit mode turned on, then we can access the study. So we access the study, we go to the output pane, and we make sure that we click on set as active time depth relationship, and we'll get a warning saying that that already exists. Do you want to override it? Say yes. Okay, now whenever we change anything in our well correlation, the top will update based on our current time depth relationship. So let's look at our well correlation and find Rocky 1, which is there. And so if we go into Statigraphy and choose Edit Well Tops, we're now in a position to put a well top in. We need to go and find our well top that we want. In this case, we want the F100 fault, and you can just make these by going insert well top and giving it a sensible name. I like to make sure that the color of the formation top is the same as the color as the fault. So in this case, we would change that to green. Okay, so I'll move that out of the way. F100 is active, and I'm just going to take a wild guess and say there. And you can see I'm too deep. Immediately that top is updating on our section, and so now we can drag that well top up and try and find somewhere sensible. So maybe here. No, still too deep. Once you're in the right ballpark, you can use the log signature to pick a spot that makes sense. So in this case, I'm going to take that sonic break and that density break, and I am on the money. Okay, so now I know where it is. What do we do about the missing section? First of all, we can right click on it and type in an amount. Let's say minus 500. Okay? Of course, nothing happens. That's because we are in SSTVD mode at the moment. What we need to do is change to true stratigraphic thickness. But before I do, you need to run the thickness calculation. To do that, we go over to Wells, open up the well settings, go to the thickness tab, make sure that the markers that you're interpreting with are the markers that are shown in here. Make sure that assume the undefined dip and azimuth are 0 is turned on, and then go down and hit run. It's not okay just to press OK or apply, you need to press run. When you press run, you will end up with an entry in the global well logs called true stratigraphic thickness. Once you have that, you can now turn on true stratigraphic thickness in here. Okay, so now you can see I've got the fault in for all the other wells, and I might zoom out a little bit. And let's now have a look at whether that's making more sense. So now all of our formation tops are roughly parallel, so that's already a very good start when you compare that with SSTVD, where things are up and down depending on how much section is missing in different wells. So back to TST. The next thing that we can do is we can open up the spreadsheet. If we do that, we go to well markers, we open up the spreadsheet, and hunt around for your well. Use the filter, however you like to do that. And you can see that a missing section is nominally 500 meters. Notice that it's negative, negative for missing, positive for repeat section. So given that, we now have to figure out whether that's the right amount, and we can also put in the dip angle and dip azimuth. Now, the dip azimuth is easy to figure out because we've done some interpretation. So if we go back to the map, we can see that this fault system runs just west of north in terms of its strike, which means that the dip azimuth is going to be 90 degrees greater than that. So let's say 85 degrees. So over here we can put in a dip azimuth of 85 degrees. And the dip angle, we can take a wild guess and let's say 40 degrees and hit apply. And you'll notice over here that our well top is no longer a square, it's a disc, and the dip of that disc is and the strike of that disc is the numbers that we've put in here. So you can see that that dip is too great. So now let's just change that to 22, because I think that's the number that I know is correct. And sure enough, now we've got something that's running tangential to the fault in that spot. So that's great. What about our throw? So let's go back to our section, and you'll see now that our well, this section has been dramatically reduced on what it was when we had it set to 500 with no dip or azimuth information. And that's because this number here, this 500, is the distance, the throw along the fault. It's not the vertical offset, it's the throw along the fault. And if you've got a low angle fault, then that number has to be appreciably greater. So let's try 1000. Hit apply. And it updates, but it's still not enough. So let's try minus 1570, because that's the right number. And now you can see that, assuming that there's no significant thickness changes away from the well, that our